Welcome to my channel. Today I'm going to discuss the angle that light rays are going to hit the earth from the sun, because I came across a video of a flat earther who was suggesting that because the light rays are actually coming in slightly off from just exactly parallel, that this somehow was going to affect the seasons, and so therefore the globe earth model wouldn't work just because the earth is tilted 23.5 degrees. So I want to cover what the angle variation will be for the greatest variation for a light ray coming from the sun and hitting the earth. We'll start with our little earth, little blue ball over here on the right, and the sun over here on the left. The greatest angle of variation is going to come from a light ray from either the top or the bottom of the sun. We'll work with the top of the sun, but the light ray leaving the top of the sun and coming and hitting the bottom of the earth would be the greatest angle variation that you could possibly have in this model. So a light ray leaving the top of the sun and striking the lowest part of the earth that's visible to it would be the angle that deviates the greatest amount from 90 degrees. A light ray that is going directly from the sun, directly to the equator or the center of the earth, will be at 90 degrees relative to the axis of the sun, the vertical axis of the sun. Alright, so to figure this angle that it's going to deviate from the point on earth looking back at the sun, the angle of arrival for that particular ray, the greatest deviation from 90 degrees, will be referenced to a point here on the sun, which is actually one earth radius off from the actual center of the sun. So we take the radius of the sun, and if that line coming across is going to hit right in the middle of the earth, so we must go down one radius of the earth to get the actual length of this side of this right triangle. So from that we can calculate what the angle is over here, and we'll proceed to do that using again the tangent function, which is we used in the last video, and we can figure out how many degrees of variation we're going to get from a light ray that's up here coming down from the top of the sun and one that's coming right straight across. Alright, we know the radius of the sun from yesterday, and the radius of the earth, of course, is 4,000 miles. So you add those together, you get 434,143.6 miles. So that's our length of this side of the triangle. We know that the distance from the sun to the earth is 1 AU, or 93 million miles, so that will be the adjacent side to our angle that we're going to be calculating. From that we'll use the tangent function, and we'll calculate the tangent of the angle that we're trying to find here. Remember, the tangent function is, for the angle that we're measuring, is the opposite side of the triangle, the length of the opposite side, divided by the length of the adjacent side. And that will give us the tangent of the angle. So we have the radius of the sun plus the radius of the earth divided by the 1 AU, and that gives us 0.004668 for the tangent of this angle theta. And that brings us to 0.267 degrees. So that's how far off from 90 degrees the angle from a light ray coming from the top of the sun down to the bottom of the earth. That's the maximum deviation you can have for an angle of a ray coming from a photon, coming from the sun and hitting the earth. Now remember that the earth is tilted at 23.5 degrees, and this is variation as we go around the sun is what's going to give us our seasons. When our earth is tilted in such a way that the northern hemisphere is pointing towards the sun, it's summertime in the northern hemisphere. come around to the other side, then the southern hemisphere is pointing towards the sun, and it's summer for them and winter for the north. That is how our seasons are created and explained by the globe model. Well, 23.5 degrees is a huge number compared to 0.267 degrees. In other words, effectively, for the amount of watts per square meter that is hitting the Earth, the difference is insignificant. This is nothing. 0.267 degrees is so tiny it can be safely ignored. I hope you found this useful, and I'll be covering other areas related to this, including the eclipses and whatnot, in future videos. If you enjoyed the video, please click like, and if you haven't done so yet, please subscribe, and I'll see you next time.